And welcome to the Daily Space Weather. I wanted to take a brief moment here to thank all of our new subscribers. So thanks from the bottom of our hearts at the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Here's the past 24 hours of the closest star. You may refer to it as El Sol, Helios, the Sun, the local yellow dwarf, etc. You're looking at ionized helium here in the extreme ultraviolet wavelengths. Here we've added some ionized iron. That's 195 angstroms along with 304. And we just had a massive crown prominence. So you may see a coronal mass ejection happening. There's also a halo coronal mass ejection. Would that be an earthly directed coronal mass ejection? Well, don't worry. We'll let you know later in the video. Here's the equatorial region in those wavelengths. We've got activity setting in the northwest and some activity moving toward the center disk from the east. Besides that, no major changes since yesterday. Let's take a brief look at the southern heliographic polar region. Huge filament over here rotating out. And wouldn't it be hilarious if the Sundar Pichai filament shut down the power grid? Anyway, let's take a look at what's going on in terms of sunspots. So there you have yesterday plus today. No major changes there. I don't see any new groups likely to get named. And if we've missed something, let us know in the comments. Here's a colorized magnetogram, also from SDO, the past, well, yesterday plus today so far. Let's take a brief moment to see what's going on around planet Earth. Well, starting out with volcanoes, Popocatépetl must be erupting. There's a great image of a spectacular eruption happening yesterday on the 21st. Also, Nyamuragira producing an effusive eruption there, visible from Goma City once again. That's located in the Democratic Republic of Congo. All right, so let's run down the list here to see what's erupting. Etna remains on the list. Unstable activity continues for the past couple of weeks at the Sicilian volcano. A new lava flow at the southeast crater rim. Etna, it's erupting. Sakurajima also erupting in a fashion to produce an 8,000-foot plume of volcanic ash. It's a flight level 080, flight level 060 from Mount Ibu. Semeru exploding, flight level 150. It's a 15,000-foot ash plume. Dakono, 6,000-foot ash plume as it explodes. It's located on the Isle of Halmahera, Indonesia. And there's Popocatépetl exploding, continued with its uptick there in activity in central Mexico. 32,000-foot ash plume listed once again. Popocatépetl there exhibiting an uptick. Sangay also exploding, flight level 190 from Sangay in Ecuador. 19,000-foot ash plume, 14,000-foot ash plume from Revenador. Sabancaya unable to detect, don't assume it's not erupting and get inside the exclusion zone. And Nyamuragira in the Congo, the Democratic Republic of Congo. Next, we'll get to earthquakes, but first, take a moment to visit our links. You'll see a paid promotion link for this video. That is the Hemp Lucid shop. So you'll find a link below this video in the description section to check out the Hemp Lucid shop, whether you're looking for CBD tinctures, mushroom gummies, other CBD edibles, Delta 8s, even THC-free products. Available from the trusted source, hemplucid.com. And don't forget to enter the promo code SMASHOMASH to save some money on checkout. That's a 10% savings available to our viewers. Enter the promo code SMASHOMASH to save 10% on your checkout, or just shop via our link. Again, it's available below this video in the description, as well as on our homepage at smashomash.com. Today's featured product is Shartlight. What does that mean? Well, to Shartlight is a failed attempt at gaslighting. So don't try to gaslight people on the internet who have better memories than you. That is a recipe for disaster. And when you fail at gaslighting, what you've done is you've Shartlighted. Think about if you tried to ignite a fart with a lighter, but instead you crapped on your hand in the lighter. That is what Shartlighting represents. It's a perfect metaphorical allegory for attempting to gaslight people on the internet and failing. It's very simple to simply admit when you're wrong and move on with life. However, painting yourself into a corner and never coming out is detrimental to one's credibility, just like failed attempts at gaslighting. Don't attempt to psychologically torture people by gaslighting them, and hopefully if you do, you'll fail. By the way, that's part of our mission, is to not gaslight people. It's to assist, study, and report on the ongoing formation of a unified theory of physics. You can read about it yourself if you like at smashomash.com/forum/mission. Another purpose is to raise the awareness of the general public of the relationship between space weather and Earth effects. Space, it's pretty weird. Yeah. Also to connect and consult with media organizations to multiply our reach. Press the share button to help us with that portion of our mission. To demonstrate cutting-edge proof-of-concept solutions to problems. We've done things on the channel like grow tomatoes and potatoes indoors over the wintertime. Also to publish scientific papers in a multidisciplinary manner. We will be attempting to push forward cosmology to start things out, also heliophysics. And then it's anybody's guess where we'll end up next. Also to assist mankind by advancing the study of predictive phenomenon to optimize value, reduce risk and liability, and save lives and resources no matter what the adversity is. And lastly, but not to be ossified in our beliefs. If you're ossified in your beliefs, you're doing dogma, not science. By the way, check out the Amazon shop as well if you'd like to support our mission. Some products there which will help you out in your shopping process on Amazon. And let's see what's going on seismically. There was one large quake in the past 24. It was a 6.8 magnitude. That's a 90-day bar graph there to conveniently show you seismicity. And there is that 6.8 magnitude quake. It occurred south of Africa. The time was 14:56 Universal Time yesterday. Not a lot of people around to feel that. 6.8 near the Prince Edward Islands region. And let's check out the list here, citing quakes over a 5 magnitude. Tonga saw a 5.2. Quite a few quakes here over a 5 magnitude on the list. Again, that 6.8 was at 14:56 Universal Time yesterday. And there is a 6.1 magnitude aftershock. Oh, that's not an aftershock. That is an aftershock near the Solomon Islands there, following some large quakes in that region. And again, you'll see aftershocks near the Prince Edward Islands area. Largest quake for quite a while here off the coast of California. There's a 5.5. Let's hope that's not a foreshock. That could be a foreshock. So keep that in mind. Let's just hope it's not. 5.5 there off the coast of Petrolia, California at 18:44 Universal Time. Let's take a brief look at where that's located. There you go. All right, off the coast there of Northern California. Let's get back to our list. Papua New Guinea had a 5.3. Macquarie Island had a 5.4. 5.5 at Japan, 5.0 at India. So quite a lot of quakes here in the past 24 hours. The Banda Sea had a 5.2. The Loyalty Islands had a 5.5. That's an aftershock. 5.1 at Japan. So quite a lot of quakes there. Let's hope None of those are foreshocks, as they may be the predecessor to a larger event. Moving right along, let's get back to space. Here's the past 24 hours and 171 angstroms from the GOES-R. How about some money shots? Well, we've got some splintacular zoom-ins. There is your eastern limb, the source of most of the flaring over the past few days. By the way, the flare profile has not dropped yet, so we're still in like a low-level C-class solar flaring range. Here we've added 284 angstroms to add some additional depth to the solar corona. Once again, there is the eastern limb. Several large sunspots occupying the east portion of the closest star. And let's get back to some stats. The 10.7 centimeter radial flux has descended to 163 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 Janskis of radial flux density. So that's just a measure of electromagnetic radiation traveling through space. 163 solar flux units is the current 10.7 centimeter radial flux. Space Weather Enthusiast dashboard here forecasting some geomagnetic storm conditions and unrest conditions late in the day tomorrow into early in the day on Wednesday. So there you go. That's the NOAA forecast. That's a result of coronal hole high-speed streams. I'm not sure why it's going to be so up and down according to NOAA. I sort of don't really think that's the way it's going to play out, but that's NOAA's forecast. We've reported it. Let's move on to take a look at Earth's magnetic moment from space for the past 4 hours. By the way, we did have a brief period of geomagnetic storm. We saw it all the way up to KP6. It was a result of basically just magnetic fields by itself. Again, this is the last 4 hours of Earth's magnetic moment. Out to about 12 Earth diameters, it depicts magnetohydrodynamic pressure, nanopascals. Next Earth magnetic moment from the ground, also the past 4 hours. You'll see things calming down here as far as geospace delta B. That's changes to Earth B field in nanotesla, magnetic flux density. At the ground level, Earth's magnetic moment from the ground for the past 4 hours. KP index is currently at KP3. Back to geomagnetically calm conditions following a brief period of KP 5.67 and then KP 6 and then back down to KP 4.67. So about a 9-hour brief geomagnetic storm there. It was pretty minor, and it was caused by basically just magnetic fields, not much more. A small uptick in the solar wind speed, but it was really this area right here where you saw the BTBZ, which is that top line right up here, reach 11 nanotesla for the total field at Lagrange 1, with a BZ of -11. That induces current into the earthly system. That is what caused the brief period of geomagnetic storm conditions. It was accompanied by a very low solar wind density there, only around 1 proton per cubic centimeter. And that quickly subsided there because the field changed. The total field weakened. The BZ signal weakened and was kind of sputtering. Solar wind speed did reach up to just over 600 kilometers a second there. It's already been subsiding. Current conditions showing up as 536 kilometers per second for the solar wind velocity, solar wind density just under 3 protons per cubic centimeter. Again, more geomagnetic unrest and storm conditions likely coming in the next day or two. GOES magnetometers there, pretty spiky readings. Got some pretty high readings here, actually. If you look at the 7-day chart, not quite as high as it was on the 19th. Stronger fields there than yesterday, though. And let's take a look at the heliospheric current sheet. So here's our top view ecliptic plane field plot. Earth remains in a South Pole current sheet. There's a North Pole current sheet over there. It's about 2 or 3 days away yet. Here's our line of sight field plot. Again, Earth is just in a South Pole current sheet here at the moment. Keep in mind the magnetic environment can change suddenly and with basically zero warning. For example, if a large sunspot suddenly appears, that will change things. Next, coronal holes. And let me cue up the SDO imagery here briefly. There's our coronal hole line of sight plot. We do have some North Pole oriented coronal holes peeking out of the southeastern limb. Probably not visible yet in 211 angstroms SDO. Right down here, expecting a North Pole coronal hole there to rise. This one here quite well defined here, and that is the one that we're expecting the high-speed wind in the next day or two. So that's the 211 angstroms wavelength there from SDO. My favorite wavelength to show coronal holes. And moving right along to sunspots. Here's the current situation. No new named sunspots here since yesterday. So it's a stable situation when it comes to sunspots. And let's take a look at the SDO intensity gram here in gray. There is yesterday plus today. A little bit of mild growth here behind this large sunspot in the southeast. There also is a high likelihood to see a large flare from the northwest. We've still got magnetically complex groups setting up there. That does increase the probability of a large flare. We have seen the activity coming up a little bit in the northwestern limb. As far as energetic particles go, we don't have any spikes in the proton flux. Proton flux remains flatlined there. And again, the flare profile is still at about a C2. We have about a C2 background X-ray flux. So that's still quite elevated. That's probably going to drop today as those groups set in the northwest. But they still do have a propensity to produce some large flares as they do so. So that'll be something we'll be monitoring throughout the day once again today. Also, we've got magnetically complex sunspots all over the Earth-facing portion of the solar disk. Here is yesterday plus today in 94 angstroms. We're going to zoom way in. So that is May 21st and May 22nd so far. Don't be surprised to see a large flare from this group over here. It's at the moment for the next about 12 hours. That'll be the most likely place, in my opinion, to see a large flare. And if your opinion differs from mine, let us know in the comments. Here's the past 24 hours in GOES-R 94 plus 131 angstroms. Again, that's 24 hours, as the daily space weather videos give us the convenience of showing 24-hour videos daily on the channel. And if you're new to the channel, don't forget to press the subscribe button. Congratulations on realizing that it exists. And good morning to you, Robert. Continuing on. It's time to take a moment to see what's going on overhead. So here's what's going on overhead Lehigh Valley, Pennsylvania. If you want to make your own star chart, head to skyandtelescope.org. If you're up before dawn, you might catch Jupiter and Mercury rising ahead of the sun. And if you're up after dusk, you might see a crescent moon and Venus not too far apart in the sky there. Great night to view the moon and Venus. A thin sliver crescent moon there, just ahead of Venus, slightly north of the ecliptic. Here's your solar system forecast. This is where heavenly bodies are now. That's where things will be in 1 week on May 29th. Keep in mind that is not to scale. It's from theplanetstoday.com. Next, looking at coronagraphs. And like I said earlier, we've got a halo eruption. Is it earthly directed? You're not going to see it in this imagery. That's yesterday's coronagraphs. That's 105 frames from George Mason University. And here's today. You'll see a halo coronal mass ejection where it looks like a halo. That is consistent with earthly directed coronal mass ejections. However, this one is not earthly directed. It came from the far side of the sun. We looked pretty closely. Here are your LASCO coronagraphs, C2 and C3. The last imagery we showed is the C2 coronagraph as well, by the way. And you see that crown prominence coming out of the northern hemisphere. That's unlikely to have any earthly directed components either. And there you see that halo coming out around 1 o'clock this morning universal time. Don't worry, we've got some additional coverage of that just to verify that it is on the opposite side of the sun and not earthly directed. So here are some coronagraphs. We've got stereo A, which that's the location of stereo A. We just show that daily because stereo A is now so close to Earth, unfortunately. So here we are, 1:23 universal time on stereo A. You can see a halo there. And 1:30 universal time on the Soho LASCO C3, and you see a halo there. So we'll let those play through for a brief moment here. Let me bring these back, actually. Please keep note that these are not synced. The imagery does include time and date stamps at the bottom, so pretty close together this time. That's pretty good. And here early this morning, you'll see that halo eruption. A coronal mass ejection that shows on all sides of the coronagraph is often a feature associated with Earth-directed coronal mass ejections, but this time not so much. So if we look at the 195 angstroms wavelength, you would expect to see some plasma moving around early this morning. And you don't really see it. An indication that the CME came from the opposite side. So here is our composite imagery. There's 195 angstroms, as well as Soho LASCO C2 and C3 together and synced. The hell? Great halo eruption, followed by a crown prominence CME. But at the time when you see all of that explosion happening there, you don't really see any plasma moving around in the Earth-facing portion of the solar disk, an indication that it is on the opposite side of the sun. So sorry if you were hoping for aurora at mid-latitudes, it's still kind of unlikely. Here's a close-up of the 195 angstroms wavelength from the GOES-R. There's some pretty sweet imagery. Huge plasma filaments, by the way, which we will show you next. So check out the plasma filaments. This is our hydrogen alpha ground-based solar observatory in Udaipur, India. And you see all those dark absorption features overlapping the solar disk and a bunch of bright emission features hanging off the edge of the solar disk. Those are all solar filaments. So quite a lot of filaments. These ones up here are on their way out into the greater solar system. At least part of them is. Likelihood for coronal mass ejections remains at nearly 100%. We've even named some of these. This is the Sundar Pichai filament, and this is the Edward C. Scott filament. This one right here. I picked a good one. And thanks to our viewers who follow us on Twitter. Hilarious tweet about Meta, one of the most pathetic software manufacturers in the history of mankind. Meta, a hilarious joke disguised as, quote, social media, end quote. Social media, it's about as social as locking yourself in the basement with a bottle of vodka. Here's that prominence that we were talking about. That is a spectacular crown prominence. And a large percentage of that material is off to the races, blasting out into the solar system in the form of what we call a coronal mass ejection. That is the past 2.5 hours from the GOES 16 SUVI. Lots of solar filaments hanging out at the moment. Let's blast through bonus features, starting out with satellite charging hazards. At the moment, satellites do have some some surface charging hazards here in the Eastern Pacific. Those surface charging hazards created by low-energy electrons building up on the outsides of the spacecraft. You may see some minor communications errors on those spacecraft. Things like the GOES West might show some interference if you watch those throughout the day, a corroboration of factual data, something we do every day on the channel. Next, the GOES electron flux here briefly got into warning levels there, which was kind of surprising. Those are the greater than or equal to 2 mega electron volt electron fluents. There's a 1-year graph to put it in context. That is from solon.info if you want to look at that yourself. And there is the NOAA forecast. Levels getting a bit higher there than expected. I'm not sure about this coming forecast, but we'll have to see what happens there. No direct argument from me. Those electrons are measured at the F layer of the ionosphere, which is located at 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with the chemical concentrations, temperatures, and electromagnetic radiation penetration of the different atmospheric layers. Here's one slice, the F layer, the bridge between Earth and space, at about 300 kilometers of altitude. Here's the anomalygram on that same data. That's anomaly in megahertz from a 30-day median. Quite a lot of low-frequency anomalies here. So the ionosphere has puffed up again. It is a thing that you will see typically associated with geomagnetic storm conditions. An increase in low-frequency anomalies on the ionogram. Again, that's anomaly in megahertz from a 30-day median. Low-frequency anomalies are the story of the day as far as the ionosphere goes. There is your latest image, 11:30 Universal Time ionogram and anomalygram. Total electron content depicts free electrons from about 12,500 miles of altitude, where your GPS satellite is located, the inner portion of the outer Van Allen belt down to the ground level. Those free electrons cause signal refraction, and here is a forecast of that. So some electrons, what you'd call out of place here. That is typical that we would see with coronal hole high-speed stream impacts. Those are the most likely places to see GPS errors. Try turning on Wi-Fi location accuracy. If you've got hotspots, that can help you navigate. Here is the total electron content 10-day anomaly I'm sorry, this is the difference from the 10-day average. It's essentially an anomaly gram for the total electron content for North America. And at the moment, only some minor fleeting anomalies over North America. We'll close out the space weather section of the video with the latest intensity gram and latest SDO magnetogram. Let's check out this sunspot real quick. It looks like it might have grown a little bit since yesterday. It's still, I don't know. I mean, that might be, the best bet on this one might be to say that it's part of this sunspot, just very far apart from those other umbrae, as it's you've got North Pole umbrae there. So it's, I mean, if that's the case, then you could consider this sunspot group a beta gamma delta class group. So that's interesting. I mean, that does increase the probability of flares a little bit from that sunspot group. It has done some activity in terms of solar flaring. The rest of these groups have been pretty stable since yesterday. Take a brief look at these magnetic fields. That's beta gamma class, beta gamma delta class also. This one is a beta gamma delta class as well. There is still a high statistical probability of large solar flares based on magnetic field complexity. Anyway, let's move to meteorology, and we're doing some wave chasing. So the world's largest waves here are located in the West Pacific, north of Papua New Guinea. They're only about 30 footers. They are associated with that tropical cyclone. Bigger waves there in the West Pacific than you even get in the Southern Ocean. Anyway, let's blast through meteorology. Here are the surface winds. Of the eastern world. Here are the jet streams of the east. Jet streams of the west. Pretty incoherent jet stream there over the western U.S. Interestingly, a lot of incoherent people flapping their lips in Colorado. Maybe it's related. Here are the surface winds of this side of the planet. The North Atlantic remains windy. Here are the surface winds of Europe, Africa, and the Middle East. And there are the jet streams. Let's take a look at clouds and fog. But first, soil anomaly, soil moisture anomaly. So center part of the country quite dry, also the northeast quite dry, the southern part of the country kind of wet. That is your soil moisture anomaly. Most of New Jersey there seeing like 2 inches below normal rain or below normal soil moisture. Anyway, let's move on to look at clouds and fog. This is 3.9 micrometer radiation. This infrared spectra show us clouds and fog when it's too dark to use the visible satellite, as the sun's just rising over the Atlantic. That's what's going on from a satellite's perspective. Next, your weather.gov map. If your location is lit, head to weather.gov and click your location. There are too many weather warnings to show here, although we will briefly show you the key. Looks like we got some flood watches around the Florida Panhandle, southern Georgia, parts of Alabama, and parts of Mississippi. Some air quality alerts in Montana, thanks to Canadian arsonists. Continuing on to some weather forecasts. Here is your temperature anomaly forecast based on the GFS model for the next 72 hours. We like to show unseasonably warm and cold temperatures. That's where things will be for the next 72 hours, most likely. We show 72-hour forecasts on the channel because they tend to be accurate. Unlike hack frauds that are showing you 3-week forecasts and telling you that there's going to be a blizzard and a year without a summer and all this other untrue nonsense. Next, your pressure and precipitation forecast for the same period on the same model, the GFS 72-hour pressure and precipitation forecast. We'll also show lightning. And it's been quite active around the Americas for lightning over the past about 10 hours. Quite a bit of lightning there. And let's see what's going on in real time. Quite a lot of lightning continues on a worldwide basis, all around the Mediterranean, all around Central America. Quite a lot of lightning there in Eastern Europe. Also Turkey experiencing some thunderstorms. By the way, if you enjoy the content, don't just press like and subscribe. Get additional content by becoming a member of the Smash Team at smashomash.com/Smash Team. It's our official subscription services site. Become a silver or gold level if you'd like to support the channel and, again, see additional content. There's also a bronze level. We do send out email alerts when we put out videos like this one, as a lot of people do not seem to get notifications from certain video hosting websites. Anyway, you can find our links there, smashomash.com/Smash Team. Thanks especially to the Gold and Silver Smash Team members. They contributed to this video by helping us obtain this computer. Yeah, this computer, the one that we're making this video from. We've recently upgraded. Thanks again to the Smash Team. The best value is a gold annual paid-up subscription. It's like getting 4 months of a gold membership for free. smashomash.com/Smash Team. Links on the homepage to that. smashomash.com. And welcome to the Neo-Renaissance as we advance cosmology by advancing heliophysics, by doing something, well, we're just writing the most important science paper in like hundreds of years, explaining the mechanism that underlies the solar sunspot cycle. So get involved, help us out. Press like, subscribe, share, etc. Leave a comment, tell your friends and foes about the channel, and consider becoming a member of the Smash Team. We will close out the video with U.S. Doppler radar. Clouds and fog over the lower 48. And the water vapor map. How about a recap? U.S. Doppler radar. There is cloud cover. Once again, it's a 3.9 micrometer infrared radiation map. And there is the water vapor map. We highly recommend using the water vapor map if your Doppler radar map is unclear. And if you're aware of basic things about atmospheric physics, like that this pressure is going to be a relatively high pressure compared to this lower pressure over here. Why? Because nitrogen is more massive than water vapor. Yeah, nitrogen, aka dry air, is more massive than moist air. And by the way, our coverage of the sun and Earth weather is more massive than anybody, perhaps in the known universe. Anyway, thanks again to everybody who's tuned in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And may that solar wind be at your back.